Hi, thanks for joining me today for the Developing Turnkey Devices for Edge Use Cases talk at the Edge conference. My name is Mark Abrams. I'm a field engineer, Edge specialist with Rancher Labs. So turnkey solutions are essentially those devices that we just want to have somebody receive a piece of hardware, have them plug it in, turn it on, and it just works. And today I'm going to talk to you about creating turnkey devices using Kubernetes as the system of management. Really, turnkey solutions at the edge can be looked at as personalized appliances. And I don't mean personalized necessarily to an individual, although it could be. But also just to the site-specific location, geographically located. So you know something about where it's going when going into it, but you also know that you need information that you don't have when it gets set up and configured. So in the past, this was done through SneakerNet. If you don't know, SneakerNet is when a human was required to set up and manage the system, and they would come in with a CD or a USB stick and insert media into the device, and then basically physically make modifications. This could take a day or a week or more to get the system into the desired state. So for turnkey devices, what we've seen is that at least some level of connectivity is going to be required. This isn't necessarily true for my use case. For what I'm going to show you today, I do expect connectivity is required, and there might be some network latency at the locations that I'm sending this to. Or networks might get disconnected, and that seems to be a common scenario we see a lot in actual real-world cases, as well as zero trust security. And I won't get into security today, but those are all things that we see very frequently in the same space with turnkey devices. So turnkey devices using Kubernetes, K3s, we're going to use K3s to do that. And K3s is container orchestration. It is Kubernetes. Kubernetes, basically, why Kubernetes on the edge, right? So why not simply build embedded systems to solve the turnkey problem, or for that matter, just run a container runtime like Docker on these systems? Kubernetes gives us some advantages that these other solutions don't. Kubernetes allows us, first of all, to declare the desired state. So Kubernetes will do some of the management of making sure that the system continues to operate in the state that we want Kubernetes to run in. Kubernetes is built to manage containers, so you don't have to, right? So if I just run Docker, how do I make sure that if a container fails, that it restarts, or that it restarts in the right way, that it does the right thing? There are some things you can do with Docker containers to make that happen. It's obviously not as robust as Kubernetes to do that. In addition, in some edge use cases, there are multiple devices that need to get set up as a unit. And so the ability to cluster those devices in a turnkey fashion is also a really nice option. K3s helps us isolate the hardware from the software. So we can use K3s to manage the hardware and software components. We think of Kubernetes as a tool set to work on stateless workloads, but Kubernetes actually can manage the underlying hardware. In the data center, you just don't get that opportunity. We can easily update and upgrade without flashing the firmware if we use K3s. We can also provide reliability, availability, and scalability. Obviously, if we only have a single node, we don't get reliability, but we can take advantage of lots of the facilities that the Kubernetes provides right out of the box by using K3s. So I'm going to show you some turnkey use cases. This is, as a field engineer, I talk to a lot of prospects, a lot of customers who are doing Kubernetes at the edge, or who want to do Kubernetes at the edge. And so I hear a lot of stories about how they want it to be used. And I want to kind of share some overview of what that looks like and why people are looking towards both the edge and turnkey devices. So we have retail and branch, and these are POS systems, inventory systems, ordering, coupons, discounting, authorization, loyalty tracking. Well, this is really what you would think of in these areas. This includes not just burger joints and banks, but sometimes casinos, and big box stores. There's a lot here. The other thing is industrial IoT. And this is one that you might think is fairly obvious. Right here, we see assembly line gateways. We see messaging requirements. We see the need for, or the desire to start implementing AI and ML, as well as the desire to have redundant systems. And then, of course, it turns out the edge is not just small devices. It's not just resource limited devices. There are actually a lot of edge use cases where there's large high performance computing. They're doing AI and ML or some sort of threat detection and response. These three are not hard and fast categories. We see the energy vertical. Actually, I think there's a talk today as well that's about an edge use case in the energy vertical. That was running heavy equipment capable of very powerful compute, specialized nodes with very powerful compute, and manipulating physical systems. And in any of these use cases, you end up having specialists who know how to run and operate the software, but they don't know anything about managing the devices, and they're not the sneaker net, and you can't expect them to be. So that's where being able to deploy a turnkey device comes in, and avoiding some of the overhead maintenance of managing those systems. There are some other use cases, if we're looking at the world ahead, and some of these, this group especially, you've already heard of these. These things are happening today. With coronavirus, we're seeing thermal cameras put into public spaces, of course, self-driving cars. These are essentially, these are mobile data centers. I mean, these have a lot of compute power on them. And then in civil engineering, we're seeing, buildings, greenhouses, infrastructure, energy. Basically, as the container orchestration solution can be delivered in smaller packages, the turnkey solution is going to become imperative, right? So as we move it to smaller and smaller devices, being able to deploy that device in a hands-off fashion, and because there are so many of them, these smart devices are just not going to want to wait for embedded systems upgrades. The world moves too fast, and they're going to need to receive the changes quickly, and people want to take advantage of that. We're seeing that happening today. So I've taken all those use cases and kind of summarized what they have in common, some of the things that they have in common. One is that we often see in the turnkey use case a need to collect information from non-technical individuals. So I send the device out, and the person who installs the device really doesn't know anything about it, but they can do things like give me critical information like a store number or a network ID to get configured and set up. Then once I do that, I want to pull configuration from a remote location. Okay, now I know I can connect to the network, and I have enough information about where this device is, that I can set up the correct configuration based on what they paid for or where their location is. So now we want to actually install and set up and configure applications on the device, and possibly configure and modify the underlying system. I think it's best to actually show you an example of how this works. So I have a real live example of a turnkey device that I developed for Rancher Labs. So this example turnkey, I'll show the basically the problem statement with you. The problem I was given was on a $100 budget, we want to highlight the K3s project and lightweight Kubernetes and demonstrate the simplicity of use. So, last year the marketing team asked me to basically create something that we could raffle at conferences and events, and those were the constraints they gave me. So I was already working on this from different aspects anyways. So this was pretty much a no-brainer. We get a Raspberry Pi, an SD card, and a case. Now the case is custom, as you see in the picture here, and a power supply. We can do all of this for easily under $100. And basically, anybody with those resources can install K3s. The barrier to entry is not that simple though, right? If I just give you those piece parts, it's not just here's K3s, right? I have a computer and an SD card, and now I need to install an operating system, connect to the network, get it running. And that was version 1. So we thought it would still be cool to give away a Raspberry Pi in this cool cow case. So we did that anyway. But it really wasn't a turnkey solution at that point. This was basically, we provided a card pre-imaged with the Nvdia operating system, which is actually an installer for 5 possible other operating systems. It's an OS chooser. And then those include a couple of operating systems, an Nvdia server and a billboard service. So this was kind of like asking our end users to be their own sneaker net. If I provide you, the other problem here is that if I provide you with these resources, the Raspberry Pi, the device, and the SD card, and the noobs on it, there's no telling what you'll do, right? And we don't really care. We're happy to, give away something cool. But regardless, we settled on this as a solution briefly while I continued to develop a proper turnkey solution. So version 2 of this solution looks like this. You get the device, you plug it in, you go to a configuration page, and then you enter your credentials for the network that you select. This feels a lot more like IoT, right? This feels a lot more like what we expect a device to do today. And this is an appliance, right? It's generally something which I don't expect the end user to modify, like a toaster, right? They put bread in, they get toast out. In this case, it's just a playground for testing out K3s. Now, somewhat ironically, we are using K3s to actually bootstrap the system and run the system. And so I'm going to show you that in a demo. Now, I've pre-recorded a video of this in operation, and this starts after I've plugged in and turned on the device. But I'll walk you through it as we go through the steps. I'll actually talk through it with you. So here we have the terminal. I'm in the terminal first. And what I do here is I just give you a date stamp so that we know what time I tried to actually access the Raspberry Pi. I can't access it. However, I go into my network on my cell phone, and I'm going to select the network access point that came up on this Raspberry Pi. So here I pick configure K3s, and then I go to my web browser and I pull up the URL for this hosted site where I can enter my configuration information. I select the K3s project, I select my network, and then I put in my password. Once I've done this, I click sign in, and I tell it, go ahead, connect to the Wi-Fi. At this point, I now have the device. I've given the device all my information, and the device is now going to restart connecting to this new network that I've given it. So I've skipped over a little bit of time here, and you can see now when I log in, when I SSH to the Pi, I actually get in, and I can run a couple of Kubernetes commands in here, and we can look at the nodes and we can look at the pods. And then we'll see that at the very end, this took about 2.5 minutes total time to operate. So this is much more feeling like a turnkey device. Of course, you could put other applications on here. You wouldn't have to put K3s on here. That just happens to be the one that I ran on this demo. This is what we're approaching for turnkey devices, for solutions, for all these edge solutions that we're seeing. Let's look at it from the solution architecture perspective. So I'm going to give you a visual here. This is a visual of the architecture where what we have is that physical device, the Raspberry Pi, the ARM device in this picture. And then on that, we have the Raspbian operating system. Now in Raspbian, I've actually turned off the default network manager, and I haven't installed any other network manager. I've disabled it completely because I want to own that. I want to control and manage the network interface. And that allows me to both stand up Kubernetes in the way that I want, and also to collect the information from the user using the network, the Wi-Fi network, but then to switch it over to connect to the network that the user has given me. We could obviously do a lot more here. We could connect back to another server. In future implementations, you'll see this connecting back to a Rancher management server automatically, just by plugging in, turning on, connecting it to a network. And that's the kind of turnkey that we're looking for. So let's look at more at like the code and process to get this thing set up, and then we'll go through actually the implementation of the device as it starts up and the user communicates with it and whatnot. So first step in the build process, first of all, this is scripted. And the content, the entire thing is open source. You can go, you can pull it down, you can run it, create your own version of this. You can also, just look at it. It's everything we do is open source. Basically, these are the general steps I've outlined here, but the actual steps are in the source control process. So first of all, I'm temporarily going to configure internet access. I did this because at the time that I built this, we did not have air-gapped support for ARM devices with K3s. We do have that now, so that'll change in a future iteration. But I needed the internet access in order to install K3s. Once I have K3s, and that's basically step 2, I'm disabling the service load balancer for K3s, and I'm making sure that the host network is available to Kubernetes. And then what I'm going to do is make sure there's a temporary network. So that the Raspberry Pi, if you don't know, it has two. This is a Raspberry Pi 4B, and basically it has two network interfaces. It's got an Ethernet network interface, and it's got a wireless network interface. What I do is I bootstrap it, on the Ethernet network interface. And I do that by setting up the rc.local file to configure that network interface with a known static IP address that I can use to get Kubernetes up and running. Then, once I have that, I add 2 files into the Kubernetes, into the K3s manifest location. The manifest location allows me to run any Kubernetes configuration I want at the runtime of Kubernetes. In fact, it's not just at the boot time, but it could be during runtime. If I put something in the manifest directory, K3s will recognize it as a Kubernetes manifest, pick it up, and apply it as if I said kubectl apply. And I take advantage of this feature throughout the process. Step 5, I configure a resolve.conf for Kubernetes. There's a resolve.conf on the host, but I don't want to use that. I actually, because I'm using the network interface, I actually want finer grained control over how I resolve the network that I'm going to use. And so I use this resolve.conf, and I'm going to later change it in my process so that I can use the other network interface, the wireless network interface, later on. So at this point, I stop K3s, and I image the card, and now I can put this card into any Raspberry Pi 4, and it will function as a turnkey device ready to roll. By the way, I didn't mention, but in step 4, there's sort of a bunch of things going on here, and that's what we'll talk about in a moment. That is the process. Those are the Kubernetes resources, the containers that I have running to actually provide a user interface, change the network interface, restart K3s, all of those things. So here is our picture of our device again, right? And it's in the off state. So I have it turned off. I just have this generic device. And what I want to do is basically turn on the device. And when I turn on the device, K3s comes up against the Ethernet network interface controller. And we're basically bootstrapped at this point. I've got Kubernetes running. And so now what I want to do, and in this diagram, I don't highlight K3s, but it is still running. And in fact, it is running a custom UI and host APD. So I'm using, first of all, I'm going to use the Wi-Fi network interface controller to set up an access point. So Kubernetes is bootstrapped to my Ethernet controller, but I want to collect data from the user. And so I'm going to use the Wi-Fi NIC to do that. Once they connect, the user's driving the process. They input their configuration details and basically submit those details, and the system takes over again. So once I click, join the network, what happens is I'm going to flip it over to use WPA supplicant. So I'm going to shut down the UI components, and I'm going to restart K3s, pointing at a different entry in the resolve.conf file, and using the network that the user provided me. So I'll use WPA supplicant in K3s, that network manager in K3s, to connect to that network. By the way, there's the custom UI, which is running in Python, and there's host APD, which is similar to WPA supplicant in that it manages network interfaces, except that it's designed specifically for it's an access point daemon. So it's specifically for me to run an access point as opposed to connect to an external network. So here we have now, basically I've connected to my network, to the user's network, without knowing anything about the user's network prior to them sending out this device. The next thing is that I have, I want to show you basically, we'll go through those steps again, but I'll show you some code along the way. Here's a job. So that host APD container is actually running in a job. And the reason I run it in a job is that it really just has one job, right? Its job is to get information from the user. Once the user tells me they're done, they say connect to the network, I want the job to stop. So the job completes, and the job will run until they say it's done. So that gives the user some control here. In addition to the job in there, there's actually two containers. There's an init container, which runs the Wi-Fi, a Wi-Fi container. And that Wi-Fi container is what is going to scan the network for available SSIDs in the area, so that when the actual container that I need for the job, the UI, comes up, I can populate that container with a list of networks in the area. So that's how that works. And then in the next image here, in this next set of code, what I'm showing you is that the Wi-Fi is actually run as a deployment. Now, this deployment basically is just running that same Wi-Fi container, but in a different mode, where it's saying, I want you to connect to the existing Wi-Fi network interface controller and the network SSID that the user provided for me. So that's kind of a summary of the code and how the process works. So this slide should look familiar. The content on this slide should look familiar. What does version 3 look like? What's the next iteration, right? I think what we're looking at here are the resources for a Kubernetes controller, right? So a more generic solution here may provide a framework to do these operations, to collect information, pull configuration, install, set up, configure. I mean, that's just Kubernetes, but I can do that by dropping things in the manifest location, or to configure and modify the underlying system. There's an example of doing that in the Rancher Labs system upgrade controller, which is out on GitHub as well. What I found as I was building out version 2, and you may have noticed that I only had one option in my project options. I have plans to add some other project options. One is just run Rancher itself, the Rancher management server. The other is to connect it back to a Rancher cluster, to a Rancher management server, so that this cluster is connected to the Rancher management server automatically. The other is to connect it to Fleet, to say, hey, make this part of a bundle, or to install Fleet, right? So there are lots of possibilities. Of course, those are the apps that I'm working with. Your apps will be different. But what I found as I started building out those alternative solutions and putting in new projects is that those attempts to change the site or the user or the app specific components expose the monolithic nature of my solution. And really what I want is this, I want to abstract away the common operations into a Kubernetes controller. And so that's where this project will be going. As I said, it's an open source project. If you want to contribute to the Turnkey project, please reach out to me. If you have a need for a Turnkey solution and would like to get more information from me, please reach out to me. I'd love to hear about, your problem domain, the challenges you face, the requirements you have, and you can reach me in various ways on Twitter and GitHub. And I would like to thank you all for coming today. Here are a list of the resources that I mentioned in this presentation. And I hope you have a really great Edge conference, and talk to you soon.